Hi class, so I'm going to be talking about mechanisms today, most importantly simple machines related to levers, wheels, and axles, and pulleys. There's 6 total simple machines that we're going to be going over, but in this video we're only going to be focused on those 3. These are really the fundamental concepts of physics. We're going to be going into what a simple machine means and what it does for us, but you're going to be using simple machines throughout the year. So let's look at the 6. We have levers, wheel and axles, and pulleys. Hopefully you can think of some examples of each one. In the next video we're going to be looking at inclined planes, wedges, and screws. But the first 3, actually all of these though, what do they have in common? They all provide mechanical advantage. So what does that mean? So I'll read the definition that it says. It says a ratio of magnitude of the resistance and effort forces, ratio of distance traveled by the effort and the resistance force. So there's a couple things that I want to kind of point out. One is related to the magnitude of the forces. The other one's related to the distance of the forces. Also, I want to point out the fact that we have ratios written in each one. So if we think about a ratio, that could look like 3 to 2 or 3 to 2. So what we're going to learn is what they mean by this ratio of magnitude of the resistance and effort forces, ratio of distance traveled by the effort and resistance forces. But the point is that simple machines and mechanical advantage manipulate the speed, distance, force, and function of our device. So just to kind of put it in context, if I'm going to go up a ramp, it may take less effort for me to get up that ramp as opposed to walking up the steps. But I'm also going to have to travel a greater distance. So there's some kind of relationship between the amount of effort I'm putting in, but the distance I'm going to have to travel. So we're going to look at mechanical advantage, and hopefully you'll understand it by the end of this video. So here's a perfect example. Speaking of the ramp, this box 1, which I'll designate as 1, versus box 2, ask yourself, which one do you think is going to be easier to get up to that location at the top? You know, you're probably going to have to exert. Just think of your body if you have to climb up to the top of a landing. Which one's going to require you to put in more effort? Well, probably the one that's going to require you to go straight up and down. But the trade-off is that you're actually traveling for a shorter amount of time. This one, number 2, is traveling for a greater distance, but it's going through less effort to do so. So what about 4 to 1? What does that tell us? Well, in an example like that, it tells us that it's 4 times less effort, but it's going to be in distance 4 times greater distance. So we got to pay attention to the fact that a 4 to 1 ratio, the advantage is related to the force, not necessarily the distance. Okay, so the advantage comes in the force, but it's actually a disadvantage in the distance you're going to travel. So I don't really need to take too much time on force and what that means. I do guys, you know, there is a formula related to it, but what I do want you to take away from today is the fact that whether you're box 1 or box 2, both of these have the same work that we put into it. So the product of work will be the same regardless of the system's mechanical advantage. So it would not be proper to say something like it's more work to go straight up than to go up a ramp. They're the same amount of work. Don't confuse effort with work. So these are the same. That's the takeaway. So when is the magic number? Well, what do we mean by that? If mechanical advantage is greater than 1, so something like 4 to 1, like we saw earlier, it means less effort force but greater effort distance. If something is less than 1, so let's say I just switched it up and said 1 to 4, it means we need greater effort force but less effort distance. Mechanical advantage can never be less than or equal to 0, so it cannot equal 0 or be less than 0, I guess. I want you to take a second to think of why and what that would mean, okay? Now we're getting into the big ones, IMA. Now this formula stands for distance traveled by effort force divided by distance of resistance. This tells us that, again, if our distance effort divided by our distance resistance is greater than 1, then it means I have a mechanical advantage. So if I have something like 4 to 1, okay, and my mechanical advantage, my ideal mechanical advantage is 4 to 1, then again, what that means is that the distance of my effort is 4 times greater than the distance of my resistance. Okay. Now this is going to be, there's going to be some noted differences. If I have a actual mechanical advantage of 4 to 1, we have to understand that that means that my resistance force is 4 times less than my effort force. Okay, which means that I'm working 4 times less hard. So if both IMA and AMA are equal, and this is 4 to 1, and IMA is equal to distance effort divided by distance resistance, this means, again, that because my resistance is 4 times greater than my effort, my distance is going to be 4 times greater. So the distance of my effort is going to be 4 times greater, but my force of effort is only going to be 1/4 of what the resistance is. So note the difference. The E here, the effort, is 4 times greater, but the force is 1/4 of what the resistance is. So there's a trade-off. So that's how those two are related. Let's think of devices that have a mechanical advantage greater than 1. Something as simple as like a windmill. As the air pushes here, it turns this wind turbine at an easier rate. So there's a mechanical advantage because it takes less effort. So the force of effort is less than the force of resistance. But going back to that previous slide, which I can't do here, but think about the fact that the resistance is a lot closer to the center than the effort is. Something less than 1, a weight machine. If this was greater than 1, or because this is less than 1, you need less weights to be able to make it feel like you're lifting a greater amount. So I'm going to stop the video here because it does get kind of long, so I'm going to break it up into an intro portion and then where I actually talk about the devices.